Hello, today we are going to learn how to represent our solutions to inequalities in interval notation. So normally after you solve an inequality, you have a solution that's in a statement form, and we want to either graph it or represent that answer in what's called interval notation. So interval notation is basically showing you what interval your solution represents. So the best way to do interval notation is to always graph your solution first. So even if it doesn't say to, the best thing to do is to graph your solution, and then we will write our interval notation off of that graph solution on a number line. So remember that when you used to solve problems and you would graph your answer on a number line, that depending on this inequality symbol, you would use an open or closed circle. So for example, when you have a less than symbol, then you use an open circle on the number line. Now when writing an interval notation, wherever you see an open circle, you are going to then use parentheses in the interval notation. So parentheses basically represent that your solution is not being included, that it goes right up until that point but does not include that point. Now let's say that you have a less than or equal to or greater than or equal to. You are used to, on the number line, filling in that circle because you are including that value. So in interval notation, we also want to have a representation that we are including that value that is in our solution, so we are going to use brackets. Now here's an important concept. Wherever, if your graph comes or goes to negative infinity or positive infinity, wherever you have an infinity, you are always going to use parentheses. And that's because you can never include infinity. Infinity is infinite. It goes on for forever. So you can never include that number, so that's why it fits in with the parentheses category. Okay, let's do a couple examples. So let's say that you've solved an inequality and your solution is x is less than or equal to 2, positive 2. So we want to first represent that solution on a number line. So I'm going to find my value of 2, and I'm going to use a closed circle because it's including 2, and I'm going to shade everything that is less than 2. So that means my x values in my solution can be any number that are less than 2. Okay, so now where is my graph coming from and where is it going? Where does it start and stop? Well, anything that goes on forever to the left is going to be your negative infinity, and anything going on forever to the right will be positive infinity. So now let's go over how to represent this answer in interval notation. So I have a little trick, and the best thing to do, or what I like to do, is I like to picture that I have a little guy, and wherever he's coming from on the graph, so he came from negative infinity, he's just walking along, and then he stops wherever the graph stops. So wherever his path was, that is your interval notation, or you could just look at the graph. So how would we represent this? Well, he came from all the way to the left. He could have been walking for days. We don't know. So he came from negative infinity. Remember to always use a parentheses when using infinity. And then where does he stop? He stops where the graph stops. So that stops at 2. And because this is a less than or equal to, it's including the number 2, we use a bracket on the right side of 2. Okay? Let's try the next one. So we have negative 4 is less than or equal to x, which is less than 1. So I'm going to start by filling in a closed circle on negative 4 because it's including negative 4, and an open circle on positive 1. Now, what is our solution being represented by? X is between these two values, and it even looks like it in the solution. Our x values can be any numbers that are in between negative 4 and positive 1. So that means that, also reading it from the inside going out, x is greater than or equal to negative 4, but x at the same time can only be less than positive 1. So that means our solution for x is going to be shaded right in the middle. So if I were to take my dude and I were to have him walk along the graph from where it starts to where it ends, he starts at 4, negative 4, and that's including negative 4. He walks, and he stops at positive 1. So we're including -4 in our solution, so -4 gets a bracket, and it goes until +1, but does not include +1, so we use the parentheses. And last but not least, x is greater than 3 or less than or equal to -1. So I started with an open circle on 3 and going to represent that solution. X is greater than 3, so I'm shading to the right. Or x can also be less than or equal to -1. So I put a closed circle on -1 and shade to the left because all numbers going to the left. So how do we represent this solution in interval notation? Well, if we take our little guy, pretend like he's coming from who knows where, he's coming from all the way over here, he walks and he stops at -1. So let's represent that solution. He comes from -infinity, he stops at -1, including it, so it gets the bracket. Now he does not walk in between those. That solution is not part of our solution. So he takes a little detour, he goes whoop, and over to the next part of the graph. He starts again at +3 and then continues all the way to +infinity from there. Keeps walking until he is out of the picture. So here we have our solution, but we have a little break in between, and that's how I wrote it on the interval notation, because what's important to know is that your graph is not a solution in between this point. So we cannot include any of these values in between here. But what we do have is a total solution. We know that it can be both of these values, can be possibly be a solution for x. So to represent our solution as one statement, we use this U symbol, which represents the union of these two sets. Okay, that's your brief intro on interval notation. Make sure you come into class with plenty of questions tomorrow, just in case that you didn't understand.